That is a crazy crash, actually. From what I understand, no one got hurt. This was off of Highway 41. Anyway, just thought I'd start with another picture again because looking at these web page opening pictures are kind of boring. So here's set 5 from the practice midterm exam, number 18. Identify the symbols used for each of the following. Oh, good. It's just a good thing to do often. By the way, the symbols list is one of our approved, here it is, one of our approved sheets. So it's not like you wouldn't have this, but it's kind of overkill. So I will allow this. No, there's none of these typed out notes are allowed to be modified, with one exception. I don't care if you use highlighters, but no pens, no additional stray marks or anything else. If I see it, I don't let you use it. So that's the disadvantage. You'll be going in planning on using something that you're not going to be allowed to use. And I'm giving the same instruction to other proctors. The reason I use all these printed notes is because I know that then we all have a standard to go off of. And if we learn how to use them well, it's fair. If not, then I feel like there's a disadvantage or an advantage to others. So for example, I could highlight here some of the ones that we use often: mu, s, sigma, and so on, and just make it easier for reference. Other than that, there shouldn't be any modifications. Okay, so again, symbols table, it's in the Dropbox. If you're not getting out anything that I got, that I put in your Dropbox, if you're not finding it there, then you're going to find it in other places in the course pages. So for example, if I click on chapter contents, this is where you go to the book pages. I hope something loads. There it goes. Then there's the symbols table right there also. And that's just where I got it from, right? Okay, so going back to the question here. And it is much better if we know this by memory. Don't get me wrong. We're supposed to be able to get this down into our, deep into our mind. The symbol for the sample standard deviation is S. Let's see, is that right? Sample standard deviation, yep. And the symbol for the population standard deviation is sigma. The symbol for the sample variance, well, the variance is the thing inside the square root before you actually apply the radical. So it's going to be s squared for sample, or sigma squared for population. So once you get down one of these, you should have the other one down. Let me take you to the formula card for more reference. Here's the formula and tables card. It's inside it's a hard, like cardstock copy in the inside of your book, or you can print it on your own. And it says right here the standard deviation, blah, has the calculation there for sample standard deviation. It doesn't say sample, but it is, and that's why you need to know that these are both sample. This is a x bar, which is sample mean. The stuff inside there would be the square of it, because it's before you took the square root. That thing is the variance. So that once you get to know one, you kind of know both. One more thing I'll say about this, actually. Let me go to an old page I have from prior semester. So here are some old notes. And I think these are actually posted under the homework lecture notes in the Piazza resources page, the class page resources. And they're also, for sure, they're in the PowerPoints, and they're in the reading. But there's a nice alliteration tool that when you're talking about parameters, you're describing population characteristics, and when you're talking about statistics, you're describing sample characteristics. So let me go ahead and highlight here then what our convention is, that for population, for parameters, for population characteristics, parameters are denoted by things like mu or sigma squared, or things, Greek letters usually. And then statistics, or in other words, sample information, they're denoted by English, our alphabet, our English alphabet, like X or P and Q and things like that. But we'll also put something like a bar over it, X bar for sample mean, or P hat for sample proportion, and so on, or Q hat. So expect things like Greek letters for parameters and the regular or our English alphabet for statistics. Okay. So next question. Richter scale question. They've got all the Richter scales here. They say find the range, variance. Okay, there's a lot more to this question, but when we're doing it on a test, it's just a matter of crunching the numbers. So we put the numbers in either to our calculator or Excel or StatCrunch or whatever tool, and we're not going to really bother with all the calculations here. We should understand the calculations enough so that if there is a mistake made, we can spot it. But I'm just going to make sure, since they want, go through the list here, they want range, and I can get range directly. They want variance. So remember, hold Control or Command, click variance. And then they want standard deviation. Now once I have variance, I could just take the square root of that. But since I'm going to be able to do it directly here, I'll just do it that way. I try to use the calculation tools as often as possible because I don't want to run into any rounding errors. And sometimes we get a little lazy and we start to round off in intermediate values when we shouldn't. So, right, so here are my numbers, 296, and I'll put them in. There we go. And just another quick glance to make sure, range. And we're going out to 3 decimals, but only as needed. So 2 9600ths, variance, we've got that rounded to 3 decimals accurately, and standard deviation. Yeah, take the time to check, because on the day of the test you can't say, well, I just switched those two and didn't put them in the right spot, because I can't go back through and try to figure out, is this person telling me the truth, or do they now see the right answer, realize their mistake, and want to get credit for it where they don't deserve the credit. So please don't make a mistake there. We're all going to make mistakes. So we just got to make sure that we keep the mistakes down to a minimum and still get an A like we want. Okay, go ahead and read this one. I'm going to jump into the calculations right after, so hit pause, read it. Now this one isn't meant to be a hard one, but there's a lot of people that miss this because you're not going to be able to quickly look it up in something like the formula sheet. You'll notice here there's no coefficient of variation. You can look through. And it was in chapter 3 that we first talked about it, so you should have found it right in that box. You're not going to find it on the symbols table. Typically we just abbreviate it with CV when we're talking about coefficient variation. But you're not going to find it on the symbols table. And the fallback for me is always the review card. It's got all the basic terms, but it doesn't have them by chapter. So if I can't remember what chapter it's in, but I just know that it's a term I learned before, I might come here, and as best as I can tell, it's not here either. So it's one of the things you just kind of need to remember, and it was an important topic, or a very useful topic, I should say at least. Coefficient of variation, page number is 105. It is the way that we can compare different sets. We compare variation in different sets by a percentage, using a percentage model, when the different sets have either different units of measure, like one might be measuring pounds and one might be measuring inches, so different units of measure, or when their means are very different from one another. Now in this case, we're measuring body mass index. So in some sense, you'd think, well, okay, those are the same units of measure, so why don't you just directly compare their standard deviations? Well, we can't, because because of the time period. Remember, CV dot, the CV dot, the T part was the change of time, and so even though the means of the body mass index may be close, the fact that we've had this big change over time, and what we're trying to actually prove is that, or look into, is that the sets can be very different. So let's just figure out and remember how to calculate it. You calculate it by taking the standard deviation of the set and dividing by its mean. So we're going to calculate first each set's own standard deviations and means by going stat, calculate, summary statistics, columns. We'll grab both. Remember to grab both. You hold either shift or control. And then I actually only need their means. And I'm going to go in this order because I'm going to take the standard deviation and divide by the mean. So I'll do mean, standard deviation, and then mean. And I hold control to get that. So what it's going to allow us to do is to not only think of what the standard deviation is, which is, this measure of spread throughout the data, but it's going to allow us to do it relative to the set's mean. So how far it spreads relative to the middle of the set. And we're going to do it in a percentage calculation. So for the first one, we'll take 1.48 and divide that by 20/1300ths, and then turn this into a percent and round it to 1/10 of a decimal. So this has a coefficient of variation of 7.4. Oh, actually they want 2 decimals. Okay, so we'll go with that. 7.35. And then the other, you get the numbers for it. Standard deviation of its set divided by its mean. So see what we're doing, we're finding a relative score essentially. So on a percentage basis we've got 6.33% of variation explained by that set's spread. Is the difference between the variation of the data sets, is there a difference? Yeah, there's a difference. Percentage of basically 1%. The BMI of recent beauty pageant winners have considerably less variation. They do have less, 1% less, 1.2. There is no significant difference in variation. The beauty pageant winners before had less variation. This one's actually kind of tough. I'm going to do what I do on the test, and I'm going to go with my gut. It's a 1% difference. That's not significant, and I will take that. Let's see if I have time for one more.